Hello everyone, I am Anushka Srivastava. Welcome back to my YouTube channel. This is my 8th lecture in my data science playlist. So let's see what are the topics that we are going to discuss today. Today we are starting clustering. So what do we mean by clustering? The task of grouping data points based on their similarities with each other is called clustering or cluster analysis. Clustering is a data analysis technique used to group a set of objects or data points into clusters based on their similarities or distance from one another. The primary goal of clustering is to ensure that the items within the cluster are similar to each other than those of other clusters. This technique is widely used in various fields including machine learning, statistics, data mining, and pattern recognition to identify patterns, categorize data, and to simplify complex data sets. Now let's discuss some key objectives of clustering. Number 1. Group similar data points. The primary aim of clustering is to identify data points that are similar and group them together. Similarities are typically defined by the same mathematical distance or similarity measures. Number 2. Outliers detection. Clustering also helps in identifying outliers, that is, data points that do not belong to any group, which can be useful for anomaly detection. Number 3. Data summarization. Clustering can be used to reduce the complexity of data set by summarizing the data into small and number of groups or clusters. Number 4. Find hidden pattern. It helps to identify underlying structure, trends, or pattern within a dataset which may not be immediately obvious. Moving further, let's discuss various types of clustering. Number 1, partitioning clustering. Number 2, hierarchical clustering. Number 3, density-based clustering. And number 4, model-based clustering. Let's discuss each type briefly. Number 1, partitioning clustering divides the dataset into distinct clusters. The most common example is k-mean algorithm, which partitions data into k clusters based on distance to the centroid. Number 2, hierarchical clustering builds a tree-like structure to represent data clusters. It can be agglomerative, that is bottom to up, or divisive, that is top to down. Number 3, density-based clustering. Group together points that are closely packed, marking as outliers points that lie alone in low-density region. Density-based spatial clustering of applications with noise is an popular example. A fourth type of clustering is model-based clustering. Assume that the data is generated from a mixture of underlying probability distribution. Gaussian mixture model are some common examples. Let's discuss some popular clustering algorithms. K-mean clustering. K-mean clustering is one of the most widely used partitioning clustering algorithm. The primary goal of K-mean is to minimize the variance within each cluster while maximizing the variance between clusters. This is often quantified using the sum of squared distance between data points and to their respective cluster centroid. How K-mean clusters work? The k-mean clustering algorithms follows the following steps. Number 1, initialization. Choose the number of clusters, randomly initialize centroid from the dataset. Number 2, assignment steps. For each data point, calculate the distance to each centroid. Number 3, assign each data point to the nearest centroid, forming clusters. Number 4, update steps. Recalculate the centroid of cluster by taking the mean of all data points assigned to each cluster. Number 5, convergence check. Repeat the assignment and update step until the centroid no longer changes significantly. Moving further, let's discuss advantages and disadvantages of k-mean clustering. Advantages: simplicity. The algorithm is straightforward to understand and implement, making it accessible for beginners and useful for quick analysis. Number 2, scalability. The algorithm can handle large datasets effectively, making it suitable for real-world applications where data volume can be significant. Number 3, versatility. K-mean can be applied to various types of data and is used in numerous fields including marketing, biology, and image processing. Number 4, convergence. The algorithm typically converges quickly, often requiring fewer iterations to reach a stable solution compared to other clustering methods. Let's discuss some disadvantages. Number 1. Choosing K. The number of clusters must be specified in advance, which can be challenging without prior knowledge of the data. Number 2. Sensitivity to initialization. The final clusters can depend on the initial placement of centroid. Poor initialization can lead to suboptimal clusterings. Number 3. Assumption of spherical clusters. K-mean assumes that clusters are spherical and equally sized, which may not be equal in real-world data. Number 4. Sensitivity to outliers. Outliers can significantly affect the position of centroid, leading to misleading clusters. Let's discuss some advantages and disadvantages of hierarchical clustering. Advantages are as follows. Number 1. No need to specify the number of clusters. Unlike k-mean, hierarchical clustering does not require the number of clusters to be specified in advance. The dendrogram can help determine the optimal number of clusters. Number 2. Dendrogram visualization. The dendrogram provides a visual representation of clustering process, making it easier to understand the relationship between clusters. Number 3. Flexibility. Hierarchical clustering can use various distant metric and linkage criteria, allowing it to be tailored to specific dataset and clustering needs. Number 4. Captured nested structure. It can capture nested structure which is useful for dataset with hierarchical relationship. Disadvantages of hierarchical clustering are as follows. Number 1. Computation complexity. Hierarchical clustering can be computationally expensive, especially for large datasets. Number 2. Sensitivity to noise and outliers. Hierarchical clustering can be sensitive to noise and outlier, which can distort the cluster results. Number 3. Difficulties with large datasets. The distance metric can become very large for large datasets, leading to memory issues and longer computation times. Number 4. Irreversibility. Once clusters are merged, it is not possible to undo the merge, which can lead to suboptimal clustering if the wrong clusters are combined early in the process. Moving further, let's discuss some application of clustering. Number 1. Image compression. Number 2. Document clustering for information retrieval. Number 3. Anomaly detection in fraud detection. Number 4. Geospatial analysis. Number 5. Genomic data analysis. By this, we can conclude that clustering serves as a powerful tool in various industries, enabling organizations to make data-driven decisions, enhance customer experience, and optimize operations. Its ability to reveal hidden patterns in data makes it essential for strategic planning and analysis. So here I am ending my lecture. I hope all your concepts are clear. See you in the next video. Thank you.